Yeah, we are here. We have the files. Okay, this is a zombie mob game. We will use this
Yep.
game to learn how to use detection techniques. So maybe we can have a look of the game first. You can go to zombie mob game.py, or this one also can, cause, yeah. And you can try to run this program and see how to maybe what's the game look like. Try to run it. So
No.
you try to
Oh wait,
debug,
I see, I see.
yeah, to install the
Uh,
dependent libraries.
mm, wait, what? Oh, sure.
Configure editor tabs.
Wait, no, it's the, what's it called?
Project. From the sidebar, select project Python interpreter, then install Pygame. Pygame is a library. We need to install it for our project.
Yeah. What? Yeah, okay. 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 Oh my leg. Why? What is happening? Okay, there. What? What?
Wait.
Oh wait, did I uninstall the wrong one? Oh shoot. What in the hell? There you go. Oh my god, it's so laggy.
Yeah, I think you need to switch off, turn off some programs.
Oh yeah, right. I forgot about that.
Turn off some unused programs.
What is this? What? Wait. How do you play? What the heck? Wait, what do I do?
Use the arrow
Oh,
keys to control the player. So take maybe, yeah, the health box and avoid the zombies attack. It's a very simple game, but in
yeah.
this game there are many sprites, so we will use sprite collision techniques in this game,
Mm.
and we will see
How do
how
you win?
later. You need to upgrade this game by yourself. This is just a very simple game, but from this game you can upgrade to yours, maybe the health, the levels, and maybe the result win results, just like this.
How do I die?
Yeah.
I died and I'm still alive. What the heck?
So try to be familiar with this game first and know the functionality of this game, and later we will try to explain how to build this game.
Mm.
Okay, so turn off the window.
Okay.
Yeah. So now I will share the screen with you. So in this lesson, we will start on a new project. This one is a zombie mob game. Actually, in this game, we will use a lot collision detection techniques.
Yep.
So actually, in previous course, we have briefly used the subject of collision detection. So can you
Okay.
remember that? Where did we
What?
use the collision detection?
When when we were doing the arrow and dragon and
Arrow
player.
and dragon, yeah. So when the flaming arrows were hitting the player and the dragon, so we use detection technique there.
Yeah.
But in that game, we only use one type of collision detection. That is one sprite, one-to-one detection. Only one sprite collide another sprite, right?
How about the what's it called? The snake.
Yeah, the snake game. So what detection technique we use there?
We also, let me think. What we do?
One sprite versus sprite group, one group, right?
Yeah.
The snake sprite and the strawberry group. Okay, so
Yeah.
that one is one to a group, the single sprite to group sprites. So here,
Okay.
Pygame supports several types of collision detection techniques. So, and we will learn this in this chapter. The subject of sprite groups will also become more important. The sprite groups actually is very important. In our game, the zombie mob game, we will use a large group of zombies versus the player for some fast action gameplay.
Yep.
These are fairly advanced topics, but all of the concepts hold each other up rather than stand on their own. So the code does get easier after time, not hard. Okay. So in this chapter, we will learn how to check for collisions between two sprites. And we will learn how to check for collisions between 4 groups of sprites. And finally, we will create an awesome game called the Zombie Mob game. Okay, so we just tried the game. The Zombie Mob game is a fast-paced game in which the player has to run away from the zombies while collecting food in order to survive. So this type of game player helps to demonstrate collision testing quite well because so many sprites are involved in the game. The gameplay will be improved even further in the next chapter. In that next project, we will learn the custom levels. So maybe after you learn custom levels, then you can upgrade this game and will make this game much interesting, more interesting. Okay. So now let's take a look at the collision detection techniques. Pygame supports several forms of collision detection that we can use for several different circumstances. So why do we need so many? Basically for optimized code. So all these techniques are used for optimized code. Some forms of collision testing were involved just 2 sprites. Just like the Escape the Dragon game, only 2 sprites, right? The detection is between 2 sprites. While some test all the sprites in the entire sprite group. So it's even possible to test 2 groups against each other and get a list of all affected sprites in each group, which means we can detect the collision between 2 groups and we can return a list of sprites, a list of all the collided sprites. So this is a particularly interesting technique for a game like the zombie mob game, where there are items, sprites to be picked up, a player's sprite, and a large group of zombie sprites. So firstly, we will see the rectangle collision between two sprites. And as we can recall, I also mentioned the circular collision detection, right? Last time, I also mentioned there is another technique, is circular collision detection. So here we see this one-on-one collision testing. This is pygame.sprite.collide.rect. Here rect means it's a rectangle of each sprite. Two parameters are passed to this method. We will use this method to detect the collision. So we need to pass two parameters into this method. And each must be derived from pygame.sprite.capital-sprite. Derive. Can you remember derive?
Derived?
Yeah.
I kind of forgot.
Actually, pygame.sprite is a class. And then the object must derive from this class, which means we instantiate an object inherited from this sprite. So the object has all the properties and the functionalities of this class. So more specifically, any object can be passed as a parameter as long as it has a rect property. So the most important is the rect property called rect available. So which means the parameters we passed into this method need to have a property called rect, because the method name is collide_rect. The detection is based on the rect properties. So in the function itself, left.rect and right.rect. Here, the left means the first parameter we passed into this method, and the right means the second parameter we passed into this method. So are used for collision test, left.rect and right.rect. So if your first sprite has a rect property, then it will technically work. And the same goes for the second parameter called right. The function just returns a bool. Actually, it's a Boolean value, true, capital true or false. If there is a collision between the two parameters, between the two sprites, this function here, it will return true. If there is no collision, it will return false. Actually, we will put this collide react detection in the game loop. So in maybe each frame in the loop, when we iterate over the loop, we will check this one every time. So the function just returns bool value here as a result of the collision test. This simple function will be your workhorse for custom sprite collision testing. Actually, this function is we use very frequently in game development. Let's scroll down.
Yeah.
So here we will use our custom MySprite class. Can you remember this MySprite class? We have customized one class, MySprite class, as a basis for examples. Here is a simple one. We have this class already, then we can instantiate objects. The first is actually it's a sprite. We use this MySprite to create an object first, and then we create another object in the second. Actually, these two sprites use two different pictures. This one loads battleship, .png, and the second load robot.png. So these two are two different sprites, and they will look quite different because they use different pictures. And see here the size are different. The width, height are different. And this one, number one, is columns. Okay, right? We have customized my sprite class in previous lessons. Okay, so then we will use this method, pygame.sprite.collide.rect, to detect the collision. We will pass these two sprites into this method, first and second. This first is also the left object we just mentioned, left and right. And this is the first sprite. This is the second sprite. And we will detect the collision between these two sprites. If the result means, if the result is true, if the collision was detected, we will print some text on the screen. But if the result is false, which means no collision, then we will not run the block code here. Do you understand? Are you clear of this?
Yeah.
Okay. This is a very simple example. We will not test, we will not try it. You just read the code. I think it's easy to understand. Just create two objects and call this method to detect the collision between the sprites. So this is a collide.rect function. And also there's also a variation of this function. Variation, so that we can also use for somewhat better results in some cases, depending on the sizes of the sprite images. So the function is pygame.sprite.collide.rect. And note here we have underscore ratio for this function name. So this is a variation of the function. The difference is this function has an additional parameter that we will pass a float number here in this parentheses, where you can specify a percentage of the rectangle. We can specify a rectangle of the sprites to be used for collision. This is useful when there is a lot of empty space around the edges of a sprite image, in which case you will want to make the rectangle smaller. Do you understand this?
Yep.
Yeah, for example, maybe I can draw something to illustrate this. Say we are detecting these two sprites, and we will detect based on the rectangle. Maybe this one is a very small ball, just look like this, a ball like this. And another one maybe is maybe a kid look like this. When we use React detection, they were used based on this rect to detect. But in the real game, we looked maybe these two, the boy and the ball, maybe haven't touched each other, haven't collided with each other, but the game will detect there is a collision because the rectangle is here and here, maybe they touch each other. So maybe this is not reasonable. So we can use this pygame.sprite.collide.rect ratio to reset this one. Maybe we can set the ratio to this one to 0.5. We can write 0.5 inside. Then the rect we will use to detect will be much smaller. We were based on the smaller rect to detect. And for this boy, we can maybe set another float maybe to 0.8. So this rect will be smaller as well. And when we call the collide react ratio, and we can use dot and put object, maybe the ball and a boy inside. Then they were based on the smaller rect to detect the collision. So it will be much accurate. Okay?
Yeah.
Then let's go ahead. So this is very useful when there is a lot of empty space. Just now we saw the empty space. The syntax is a little strange, though, because the function actually creates an instance of a class with a reduction value. And then that result is passed the two sprite variable names as additional parameters. So just as I mentioned here, firstly, we put a float number into this method. And then we pass another two sprites into the returning value. Okay?
Yeah.
And next, we will take a look at the circle collision between two sprites. Circle collision is also used for one-to-one collision. Circle collision is based on a radius value for each sprite. You can specify the radius yourself or let the pygame.sprite.collide circle function calculate the radius automatically. We might want to specify our own radius. Okay, so if the radius property is not already there, then the function just calculates the radius based on the image size. The automatically created circle will not always produce very accurate collision results because the circle's radius completely encompasses the rectangle. So that is the diagonals rather than the width or height. So let's look at the example here. If pygame.sprite.collide circle, and we have two sprites first and second, then we get the results. So this is a very simple example. It will use radius to check. So variation of this function is also available with a float modifier parameter called pygame.sprite.collide circle ratio. It looks very similar to the rect method. Okay, I think it's easy to understand. Next, this one is a pixel perfect masked collision between two sprites. Actually, this one is seldom used. The last collision testing function in pygame.sprite has the potential to be really awesome if used correctly. This one actually is much more accurate than React and radius detecting. So this method is pygame.sprite.collide mask and receives two sprite variables as parameters and returning more. Look at the example here. Pygame.sprite.collide mask. Here we will create a mask for each of the sprites. Now the awesome part is how this function works. If you supply a mask property in the sprite class, an image containing mask pixels for the sprites, collidable pixels, then the function will use it, which means in previous two methods, we will use the rect and the circle. Okay, but here we create a mask for this sprite, and we will use these masks to detect the collision. So it will be much more accurate. And even we cannot see this one on the screen, but there is a mask, a hidden mask. We can use that for each sprite to detect the collision. This one, to create mask, maybe we will use some methods here, but here will be a lot of work. So unless your game really would benefit from this kind of precision, just use rectangular or circular collision instead. Okay, so normally we will use rect and circular detection. This one, you just maybe know it, then it's okay. You should know there is a collide mask, maybe method, which can also be used for detection, collision detection. Okay. So next, we will look at the rectangle collision between a sprite and a group. Now, it's a little bit different. The previous techniques are used for one-to-one detection, but here, this rectangle collision is between a sprite and a group. Hi, can you hear me? Okay, 听到我说话吗？
可以听到。
可以啊。Okay. So the first group collision function we are going to study now is pygame.sprite collide.
Yep.
So this is used for a single sprite in a group. This function is surprisingly used to considering how much work it does. In a single function call, all of the sprites in a group are tested against another single sprite for collision. So, and a list of the collided sprites is returned as a result. So here we will detect a single sprite with a group, and it will return a list of collided sprites. Okay. Okay, so, and we can also pass a third parameter. The third parameter is a Boolean value that really has great potential. If we pass in true, we look at the example here, pygame.sprite collide. Yep. And the first parameter is arrow. This is a single sprite. And the next is a group, flock of birds. This is a group of sprites. And we passed the third parameter. This one is horse. But if we pass true here, look at the explanation here. Passing true here will cause all collided sprites in the group to be removed. Here, if we write true here, we will remove all the collided sprites in this group. But if we write false here, then we will not remove the collided sprites from this group. But we will also return a list of collided sprites. Yep. Okay. So that's a lot of hard work being done for us in a single function call. See, this is only a single function call, but it returns the colliding list. So to manage the damage, all sprites removed from the group are returned in the list, which means if we remove the collided sprites from list, but if we still need to manage those collided sprites. So we return a list here. Yep. Okay. And now there is a variation of this function. This one I think we have used before. This is a variation method for sprite collide. This method is pygame.sprite sprite dot sprite collide any. We have used this one in snake game, right?
Yep.
We use this one to detect whether the snake has touched one of the strawberry. So
Yeah.
yeah, so it's a fast version of the function. This one is faster because in this method, we will return a list of the collided sprite, which means we will detect all of the sprites in the group. But this one, sprite collide any, this is a much fast function, which means after it detects maybe the arrow collide with any of the birds in this group, then it will return. It will stop. You know, so it will not detect all of the birds in this group. Once there is a collision between any bird and the arrow, then this function will stop. So this is a faster version of the game, faster version of the function.